Hello everyone, welcome to one of these new video classes. Let's hope that everything goes well with them. We're really making a big effort to just keep going with the semester as we go. This class is going to be on iterators, which is another structure we have used in the past, but we didn't know they were called iterators, and we're going to go a little bit more in detail with them. So let's get to it. So the first thing is, let's do a quick recap of everything that we've done so far. So we talked about we did a concept revision at the beginning of the CA. We talked about classes, abstract class interfaces, objects. We talked about attributes of the objects, behavior, states. We talked about packages, access modifiers, inputs. So we've been covering quite a bit. Then we move towards principle of object orientation. We talk about the 4 pillars of object orientations, which are encapsulation, abstraction, inheritance, and polymorphism. And then we move towards the collection framework. Now, your CA was heavily focused on the collection framework. And this is where we're going to start from. Now, for the collection, to be able to work on iterators, let's do a quick recap of what collections were. So a collection would be an object, like everything in Java is an object, but it's going to be an object, a special one, that is going to be in charge of collecting data, or in other words, collecting other objects. So we saw that we had different type of collections. We saw that we have sets, lists, queues, and maps. And even though maps were not really a collection, we did it together with them because a map is also a way to store objects. Now, one of the things with these 4 type of collection is that each one has its own set of rules. So in the case of sets, there is no duplicates. In the case of lists, the order is important, but there is no gaps. In the case of the queue, the order is important, and there is no gap, but I only have access to the ends of the structure. And in the case of the map, I had a set of key value pairs. So the example of the map was, for example, the phone directory. So each one of these collections, and again, maps is not really a collection, but each one of these, a group of objects, will allow me to have some other objects grouped following a particular rule. Now, what does that has to do with iterator? Well, iterators are going to be structures that are going to allow me to go over elements in a particular collection, and that's where things get a little bit more interesting. So each one of the collection implementations that we've done provide a method called iterator that returns the iterator object. Now let's think about it. For example, if I have a class of students and I have, I don't know, 100 students, I can iterate over my students going one by one at a time. So I can, for example, do an examination process. So I can iterate over the process, or I can congratulate them because they've done very well. So I can iterate each one of the objects. And that's exactly what the iterator is going to do. The iterator is going to allow me a way that I can go over each one of the elements that I have in a particular collection. And the collection itself will provide the iterator object to use them. Now, an iterator is also an object, like everything in Java, and it follows an interface. That means that there are certain methods that are enforced to be there. So in this case, in the case of the iterator, there are 3 methods that are very, very important. I have the method boolean has next, which will return true or false if my iterator has another element to go. It would be the next method would be the element next, and that is going to move to the next element in the structure, and it will return that element for me to do something with it. And finally, it is going to be void remove, which will remove the current element in the iterator. Now, another way of thinking of the iterator would be like a pointer. So let's say, for example, that this is my collection, and it doesn't matter what collection it is. Suppose that is my collection, and suppose these are all the different elements that I have in there. So whenever I create a new iterator for that particular collection, the iterator is going to be a pointer that starts outside the first position in the array or in the collection. Remember, an array is not technically a collection, so that wouldn't be a correct term to use. But suppose this is a list or an array list or any of the collections that we've done in class. Whenever I get an iterator, the iterator is going to start outside the array or the list. So if I say, if I go to the iterator and I see has next, that will return whether it is true or false, depending on the next element. So if there is a next element, which in this case there is, this thing will return true. But if there wasn't, if my collection was empty, this thing would return false. Now, the next method that I have is the method next. The method next will return not whether there is an next or not. What the next method next is going to do is it's going to move the pointer to the first position in the array. So now my iterator is going to be standing here, and it is going to return the particular object that I have in the collection. Now, if I call the next method consecutively a couple of times, each time I call the next method, what that is going to do is to move the pointer to the next position, and it's going to return the next element. So if I call it again, I can move the pointer to the next position and return the next element. So that's pretty much what the iterator is. The iterator is going to allow me to go one by one the elements that I have in the given collection. Now, enough of theory, and let's see how this translates to code. Okay, I have given you a little bit of a sample code, not a sample code, I've given you a pre-class code that you're going to use to follow along with what I'm going to do today. So let's have a look at what code I gave you. The first thing I did is that I gave you a class called a person, and that person has two attributes, name and surname, and in the constructor it only takes the name and it doesn't take anything else. By default, the surname is defined as snow. And then it has getters and setters for the names and the surnames, and I have a toString method in there. So nothing really particularly clever about this class. Let's have a look at the main class, which is my driver. In the driver, I have included a people, two array lists. There are two array lists of person, and I have called one of them people and the other one I've called it nobody. The reason is because I'm planning to leave the second one empty, so that's why I decided to call it nobody. Now the next thing that I have in here is an integer that I'm calling number of people, which is 10. The reason for that is because what I'm going to do later is that I'm going to populate the people array list with 10 people. I'm saying from integer I equals 0 to I lower than the number of people, and I++. What this for loop is doing is taking random numbers from the array of names, or random names from the array of names, and creating new instances of the person class and add them to the people object. Now, make sure you understand this line of code. If you don't, let me know in the live class and I can explain that. I can break this down for you to understand this. And then the last thing that this is doing is just printing the array of people. So let's run this to see what I get. So as I can see there, I'm getting 10 people: George Snow again, Paul Snow, Walter Snow, Steve Snow, Danielle Snow, and so on. So I have 10 persons or 10 people in that particular array list. Now, if I want to print, for example, undo, if I want to print the second array, which is the nobody, what is going to happen? Let's see what happens. What happens is that nobody is empty. I haven't populated that, and I did that on purpose. Now, the next thing that I want to do is I want to get my iterator sorted. I want to use my iterator for the first time. So to use the iterator, I just need to say iterator, and the iterator is a class, and I'm just going to define iterator of person. Why? Because the collection that I'm going to iterate over is a collection of persons. So iterator of person that I'm going to call a people iterator. Perfect. And it's going to be equals to, how do I get the iterator? Well, I just go to the collection, in this case, people, and I call the method iterator. Method iterator is going to return the iterator object, and I'm just catching that iterator object and putting it in people iterator variable. So now I'm going to do that for both of the collections just to see what I have. So I'm going to call people iterator and nobody iterator. And this is going to come from people, and this is going to come from nobody. So I have two iterators in here, one for each one of the collections. So let's see how this goes. Let's see how this works. So the first thing I'm going to do is I'm going to try the first of the methods that I mentioned to you, which is the hasNext method. So I'm going to say system.out.println people iterator dot hasNext. Because I know the people iterator, because I know the people collection has people, that value should be true. But in the case of the second one, which is nobody, that value should be false. So remember, the hasNext method, what it's telling me is if I have a next element in the iterator or in the collection. So let's run this and see what we get. So in fact, the first iterator, which is the people iterator, is telling me true, and the second iterator, which is the nobody iterator, is telling me false. So there is no first element. So that is proving, that's showing us how to use the hasNext method. The second element that I want to show you is the next element. So let's take a look at what we get in there. So I'm going to say system.out.println, and I'm going to go people iterator, then next. And let's see what happens when I do that. People iterator, that next. And I'm going to do the same thing for nobody iterator and see what happens in there. And let's run that. So for my people iterator, it's telling me Adams no, which is the first element in the array, but for my nobody iterator is throwing an exception. And the exception that is throwing is not any exception, is no such element exception. That means I don't have any element that I can give you. So from now on, I'm just going to start ignoring this guy here, because I know the nobody iterator doesn't have any element to iterate over. Now let's run this again just to get rid of that exception. And there it is. The first element that I have in the collection is the element that the next method is returning. And now what I can see here, if I go back to the little drawing that I have, I think I got rid of it. But if we remember the little drawing that we had, so what's happening is that my this is my collection with all my elements and my iterator is here. At the moment I say iterator.next, this guy is moving to the first position. So now it's here, and not only is here, it's also returning this element in here, which is the first element in the collection. So that's exactly what's happening. Now I would expect that if I call the method consecutively, if I call the method again, so it should move the iterator to the next position and return the next element. So let's see if that is true. So let's go and repeat this code again. And run it. There you go. For the first time that I call the next method, which is in line 35, the element that is returning is Paul Snow. But then also the second time that I call it is returning the second element, which is Nathan Snow. Now I can see a pattern in here. I can see that the next method is returning an object, so I can catch that object and I can put it in a variable if I need. And what type of object would that be? Well, because this is a person, I can put in a person that I'm going to call, for example, person P is equals to people iterator that next. There you go. Now, for now, I'm going to get rid of these two. Well, no, I'm going to leave it as it is. So now, something that I can do is, once I get the next, I can do whatever I want with it. For example, suppose I want to change the surname of the third person. Suppose instead of, I don't want it to be Snow anymore, and I want it to be Aponte, for example. So I can do that. I can go and say p dot set surname is equals to Aponte. So what that is doing is, for the next person that I know, because next is being called 3 times, the third person is going to have not a Snow surname, but an Aponte surname. And how do I verify that? Well, I can just print again the full collection. And let's see what happens. So as you can see there, my first element is Ty Snow, the second element is Roger Snow, which is consistent what I have in the when I print the full collection. But after I made the change, Aaron is not Aaron Snow anymore, is now Aaron Aponte. So now we're seeing what is the usefulness of the iterator. The iterator allows me to access each one of the elements one at a time, and if I want to do something with them, I can, because I'm obtaining each one of the elements in each one of the iterations. Now we're seeing another pattern here, that every time I call the next method, the pointer moves to the next element in the iterator. So I can put this in a loop. So that's exactly what I'm going to do now. I'm just going to comment these iterators out. I'm actually going to comment all of these out. And what I'm going to do is, I'm going to use a while loop for this, because again, I'm calling the next element several times. So I can say while, and then in here, in my condition, I need something that tells me whether there is a next or not. And yes, you guessed it, we actually have a method that tells me that whether there is a next element or not, which is the hasNext method. So I can say, well, the iterator, people iterator that has next. So as long as the iterator has another element, I want you to do something. For example, I can say people iterator that next that set surname Aponte. So what this is going to do is going to change the surname for each one of the elements in a consecutive way. So if I print the iterator again, not the iterator, the collection again, let's see what we get. So as I can see, my iterator has helped me go over each one of the elements in the collection, and all of them now has the same surname, Aponte, because that's what I define inside the while loop. Now, the beauty of this is whatever I need to do, I can do it because I have access to the actual object. Well, that's exactly what we have discussed now, the has next and the next methods. And I have put on the slides exactly the code that we've just done. Make sure you practice this a little bit and understand what that is doing. And something that you can do is you can test it with other collections that are not lists. So try to do it, for example, with a set, or try to do it with a queue. Now, one of the questions that somebody may ask is, well, if I can do this with a for loop or a for each loop, then what is the advantage of having an iterator? Well, something that a for each loop doesn't allow you to do is to remove elements. And that's something that you can do using the iterators. Now, you have to be careful with this one, because if you remove the element is lost. So I'm just going to show you that real quick. So instead of calling this in a for loop, I'm just going to remove one of the elements. So I'm just going to go back to the original code that we have. So we have the next, the next, the next. And if I go good and say next again, so I can say people iterator that remove is going to remove the current element in which the pointer is. So for example, the element in here is in the first, the pointer is in this first element, in here is in the second element, in here is the third element. So this is the one that's going to be removed. So if I print the full collection, I should see that the element that has surname Aponte is going to be removed, which is the third one. So let's take a look. There it is. So in the second printing, I have Jack Snow, then I have Roxy Snow, then Monte Snow is gone because that was the third one, and the next one that I have in here is Walter Snow. So my element Monte Snow has been removed, and that's one of the things that you need to be careful with the iterators. You can remove data from your data set. Okay. One of the things that, the other thing that I want to point out before we finish this video class is that, as you can see, the iterator allows me to move forward. So I can always say next, next, next. But the iterator doesn't allow me to go backwards. So if by any chance you need to go backwards, the only option that you have is that you have to reset or reinitialize the iterator. And if you reinitialize the iterator, the pointer is going to be at the beginning again, and you can do whatever you want, but always only moving forward as opposed to moving backwards. So it's just to show you that in a quick example. So for example, in this case, I know that my iterator is in the third position. So I can go and say, for example, system.out, the println, I can say P, which is the current position. So there it is. P is Mark Aponte, which is Marcus know that I've changed name, but now it's being removed. But if I go and say now people iterator is equals to, and I go and say people.iterator, what that is going to do is it's going to give me a brand new iterator, and this brand new has the pointer at the beginning of the collection again. So if I go and say system.out.println, and I say people iterator next, that is going to print the first element in the collection. So let's try that. There you go. So this is printing the first, the second, the third, but after I reinitialize the iterator, now it's going back to the first one, which is Montes now. So the iterator allows me to go forward, but not backwards. And if I need to go backwards, then I need to go with a brand new iterator and go from the beginning forward. Brilliant. Okay. That is this for this class. Thank you very much for listening, and I'll see you in the live class or in the next video.